please welcome here with me the UKTI specialist, Dr. David Hodgson.
Thanks very much. Thanks very much, and good morning. So, my name's David Hodgson. I'm a sector specialist with UK Trade and Investment. Very briefly, UKTI is a government organisation that helps UK companies to export their goods and services overseas, but then also works with overseas companies that they seek to make a presence in the UK market and help them to understand the opportunities, the market dynamics, the industry that's operating as well, and then how they can make some commercial success from a UK entity. But what I'm here to talk about really is the impact of some of the changes in our policy around decarbonising our energy system and the impact that they're having on the UK energy network. We have established legally binding targets in the UK around CO2 reduction, and this gives rise to this standard, the energy trilemma that many countries are dealing with in terms of decarbonising energy supply and energy generation, at the same time of balancing that out with the cost of doing that and the impact on consumers, but also doing that in a way that ensures security of supply. So this three-legged track that we have, the energy trilemma, is something that is a constant balance, and we have to make sure that it's managed. We're doing this in a number of ways in the UK, decarbonising heat, decarbonising transport, and decarbonising electricity. But in particular, it's electricity that has made most headway so far. We have significant offshore wind program, a world-leading offshore wind program. We have significant installations of photovoltaic technology as well. Regionally, reached 5 gigawatts last week. We reached the 5 gigawatt target. And we have a range of other low-carbon electricity generation technologies, all of which are placing significant new demands on the electricity network. And it's this area that I think energy storage has a major opportunity and role to play. I'm sure you've seen some of these graphics and diagrams before, but basically we have a very old style network here, a few centres of large power generation, and a transmission and distribution network, which is very passive, very linear. The transmission network has to manage energy quality, power quality and energy supply, but the distribution network is generally very passive in the old system. And of course we're moving to this sort of network. This is the aspiration for us in the UK to have a much more connected network, distributed and decentralised power supply, virtual power plants, large load centres playing in a capacity market, all of which is helping to balance out the variability and inflexibility of certain technologies. And it's really being driven by these factors that I've listed on the left-hand side. As we move forward, we'll have a much less flexible and more variable generation asset base. That will be generating and connecting to the network in a much different way. So it's more diverse in its type of generation, and it's connected at different points of the electricity network. Historically, we've all connected to the high voltage end of the electricity supply network, but now we're seeing connections at medium and low voltage right onto the distribution network. And we have two-way power flow as a result. So we have local generation of PV, export through an export meter that is pushing electricity up the wires in a way that the network and system wasn't designed. And as we decarbonise electricity, actually you'll see an increase in demand because it allows us to decarbonise transport, so we'll have more electric vehicles, and it allows us to decarbonise heat, so we'll have things like heat pumps being replacing gas boilers in UK houses in particular. We have a very extensive smart meter program as well, which are going to place new opportunities onto that network, new opportunities for engaging their energy consumption, and in a way that we can then utilise that information set and those connection points to be able to manage and balance the network in different ways. And then there's a role of demand-side response to come into all this as well. So it's a very different mix and one that places new challenges. We've developed a new regulatory regime to ensure that the network operators at transmission and network and distribution level can play a significant role in this low-carbon future. So our RIIO scheme, which is regulation, revenues equals incentives, innovations and outcomes, it's an outcome-driven regulatory regime. So the network operators are targeted to achieve certain outcomes rather than certain inputs. And this is really, really quite important. It gives them a greater flexibility to manage their network in a different way, provided the outcome is what was set. And in doing so, it provides greater opportunities for new technologies to be deployed. And we have a range of innovation support mechanisms at the research level, at the development level, and at demonstration to be able to assess and evaluate the opportunity and the capability of various low carbon technologies. And the little graphic here is data from the European Commission highlighting that the UK spend on smart grid technology, particularly in the area of demonstration, is the biggest in Europe. The question also comes, why are we going to do this in a smarter way? The basic answer is that if we take this approach of using conventional solutions, compared to an approach where we use smart investments, we can significantly reduce the cost of the network assets. And if we do that, some estimates have suggested the cost can be approximately £19 billion lower than taking a straightforward conventional solution. At the same time, that creates tens of billions of pounds of investment opportunity and commercial sales in this sector. And this has been highlighted by the work of EA Technology. We'll talk about their transform model just after I finish, in the way they're utilising smart technologies to come onto the network at different points in time. So where are we? Where are we? We're at a position where the transmission network has their business plan approved. They were starting in an 8-year pricing period from 2013 onwards. And it looks like there's a CapEx investment programme of around 20 billion in transmission assets, largely conventional, new transformers, new conductors, new substation upgrades, and a whole range of other things. Significant investment opportunity in that conventional technology sense. In the distribution network, they were moving to the RIIO regime from 2015 onwards, but the plans are now being drawn up. So we can see in there are plans for the distribution network companies to deploy around £1 billion worth of smart technology and around £14 billion worth of conventional technology in this next phase. But what's particularly interesting is in the 8-year period beyond that, some models suggesting that smart spend could be as much as £20 billion. And this is really important because this phase, 2015 to 2023, will be the phase where the products are consolidated and become commoditized. Specifications, operating systems will be established that will then roll out into the follow-on pricing period from 2023 onwards. But these are big numbers and big challenges, and it means there's great opportunities for companies to enter the UK market, establish UK companies, and take advantage of the changes that we're seeing in the electricity network. Just very quickly, because time was moving on, but we do now have a smart grid roadmap and vision, which was published at the end of February. It's actually a really good document and well worth a read. I've highlighted these 3 boxes here that have been devised in terms of how that roadmap might look in different phases of time. So we have a development phase, a rollout phase, and a develop phase. So at this point, we have lots of companies not only deploying technologies onto the UK network, but they have proven track records where they're able to then supply to overseas markets. And that's where UKTI can provide additional support. In the development phase, we'll be looking at new frameworks, investments in various technologies. We'll be moving demonstrations of technology from demonstrations to business as usual. And this is really important, so they're now into commercial sales of products and technologies rather than funded demonstration programs. But we'll also see things like new frameworks and standards development, particularly around regulation, to allow technologies such as energy storage to be owned by network operators, which will be a different way of monetizing energy storage technologies. And we'll also see things in the rollout phase, things like a transition from a network operator role to a system operator role. Just want to highlight that we have energy storage programs right across the spectrum, from research to commercial models being developed in the UK. But I want to draw a stop to my piece of the presentation there and move on to the next speaker. Thank you.
Thank you, Mr. Hodgson. Like mentioned, please keep your questions in mind after this technology presentations here. A discussion with question and answers will take place at 12 o'clock at the public forum, and I'm pleased then to go there and ask the question. So we will continue here right now with our next presentation, dealing with the topic Transform Model for Smart Grids and Distribution Network Operations by EA Technology, and your presenter is Mr. Mark Sprawson. Thank you.
Okay, good morning, ladies and gentlemen. This presentation is called Quantifying Uncertainty, the transform model for smart grids. What do I mean by quantifying uncertainty? Well, what we're talking about here is that our networks have been operating for decades in a very conventional way. And as we move forward now to the decarbonisation of the industry, and we have more low-carbon technologies, more electric vehicles, heat pumps, solar panels, etc., there's a real need for there to be a culture change in the way in which networks operate. And that is very uncertain for the distribution network operators. Furthermore, they need to respond to those changes by using solutions they haven't really used at scale before. So things like energy storage or real-time rating of assets. So there's a lot of uncertainty about how they do it, where they do it, and when they do it. And that's what the transform model seeks to address. So what is the transform model? Well, in summary, it's a representation of the entire GB, British, electricity distribution network. So it goes all the way from low voltage, from the point of connection of a domestic customer, up to 66,000 volts. Clearly that's a very complex beast, so we've had to make some simplifications. So it's a parameter-based model. I'll talk a little bit later about what that means. And what it does is it's based on real data from network operators, from central government, that talk about trajectories of uptake of new low-carbon technologies, also based on data from solution manufacturers, so energy storage manufacturers, for example, of the costs of their particular solutions. So we can do a cost-benefit assessment to say, where do you invest, how do you invest, and when do you invest? So this slide is just to give an indication as to why this is an issue and why it's particularly important at the moment. These are the trajectories for uptake of low-carbon technologies as taken from the Department of Energy and Climate Change in the UK. And what you can see for each of them, we've got heat pumps at the top left, solar PV top right, and electric vehicles bottom left. And what you see is, yeah, okay, the uptake levels start off fairly flat, but when they increase, the increase is dramatic. We're talking about exponential growth here in these things. Now, our networks are sized to meet certain demands, and when these demands, particularly with electric vehicles and with electrification of heating, come along, the networks are not sized to meet that, and it's going to cause them to breach their capacity, and there's going to have to be some interventions that are carried out. So I talked before that we have a parameterized network rather than a full representation of the million low voltage circuits that there are in the UK. So how have we done that? We worked with all of the distribution network operators in the UK to say, what do your networks look like? And what we find is that a network that feeds a suburban street of 3 and 4 bedrooms, houses in one area of the country is very like a network that does the same thing in another area of the country. So what we can do is we can classify circuits into families, if you like, and we have 100 families of these circuits. Now we appreciate that they're not all born equal. There are different loads that exist on these circuits, so we have different flavors within those 100. So what we have is basically you can choose your model to have as many of each of these different feeder types as you like. Each of these types has a capacity, how much load it can take. So what we then do is we overlay onto that the trajectories that we saw before of the uptake of the low carbon technologies to see how long have we got for each of these circuit types before they reach that capacity. And then what do we do about it? Well, the what do we do about it comes with the solutions. Historically, business as usual investment on the left, as Dave said before. Conventional solutions been going for decades and decades, new transformers, new cables, new overhead lines. That's all well and good, but it's not enough anymore. And what they do is they provide a kind of lumpy change in capacity, if you like. You put a new substation in, you get lots more capacity. But it's also fairly inflexible in many ways, and it costs an awful lot of money. The smarter investments, by contrast, are considerably more flexible. In many cases, they have much lower upfront costs, although they may have more running costs for demand response type solutions and so on. So what we're saying here is that going smart doesn't mean you throw away all of the conventional stuff you've been doing. You will still need new transformers, new cables and so on, but you'll need them to a lesser degree because you can use storage and dynamic rating of assets and enhanced voltage control solutions, and that's the smart solutions box there. There is one other box there which I just want to touch on briefly, solution enablers. What does that mean? That means that if you're to run a successful storage scheme, clearly you need to have some communications and control to that storage scheme. Just the communications and control don't actually give you anything on their own. They don't give you the capacity. But without them, your smart solution won't release the capacity it needs. So there's also some investment needed in enablers. So this leads to a number of investment strategies that can be developed as to whether you basically fix things when they break, which we call a smart incremental strategy. So you wait for something to reach its capacity and then you intervene. or you take a more ahead of need approach, and you actually invest in enablers in control and comms ahead of need before you invest in your solutions. And we'll see how that plays out in a second. I just wanted to include this slide very quickly because some of you might be aware of the international smart grid architecture model that is currently being discussed in many conferences. I just want to point out that the transform model is agnostic to the particular technology type used for storage, so it doesn't matter what chemicals you're using for your electricity storage, that's down at the component layer. The transform model operates much higher at the business layer, and it looks at doing a cost-benefit analysis of all the different options that you've got and deploys them adequately. So what comes out of it? Well, what comes out of it is basically a network investment plan for a network operator. Now, this is again just one example. We have many. I only have time to go through one. So these are the scenarios that are published by the government for the uptake of our electrification of heat and transport, scenarios 1 to 4, as I've called them there, how we're going to meet our legally binding carbon targets. I'm going to ignore scenario 4 because it's something of an outlier, but scenarios 1, 2 and 3, what the blue bar indicates on the left-hand side of each scenario is if we didn't do anything smart, how much would we have to spend? So if we look at scenario 3, we see it's going to cost roughly £27 billion. This is just to cope with the low-carbon technologies, heat pumps, small-scale generation and electric vehicles. £27 billion from now to 2050. By going smart, we reduce that to something of the order of £15 billion, which is clearly a significant saving. The different colour bars for the smart strategies, the red is the incremental one, which is the fix it when it breaks strategy that I talked about before, and the green and purple are two different flavours of invest ahead of need. And again, I'll just touch on those in a second. So, as Dave mentioned as well, we're moving into a new price control period in Great Britain at the moment. So we have 8 years, 2015 to 2023, where the DNOs have had to say how much money they need. And they were mandated by the regulator to use our transform model to say how much they need to deal with low carbon technology. And what this graph shows is on the left, if they just did things conventionally, it would cost £1.25 billion. By using our model and optimising their investment, it actually costs about £850 million in solutions. And 2 DNOs have also asked for some ahead of need investment to put more enablers in to enable them to meet the growing demands in ED2, which, as Dave talked about, is significant. So my final slide, just to summarise some of these points. The way in which we use the transform model is scenario driven, so we can change those scenarios to do whatever we want to do, and we can look at all kinds of envelopes of uncertainty. There's a strong cost benefit in going smart. I think we all know that. It's about 30%. We have 2 models that we developed. So we look at a national model. We can also look at more local models, looking at regional variations that exist across the country. It's worth saying that this is also applicable internationally. We're currently developing a transform model for New Zealand, and we're also in discussions with companies in Italy and France about developing a model for them. The create a framework for a consistent evaluation point is a very important one, because what the transform model has allowed is a dialogue where everyone is speaking from the same page. So the regulator, the government, the network companies, the equipment manufacturers, they all understand that they can all use this model. So what we have now is we have some equipment manufacturers who say to us, oh, what's the market size for this type of technology? So if you can give us the costs and the benefits of your technology, some of the key parameters, it goes into the transform model, and you can get a report out of that that shows your market share and how it stacks up against competing technologies. And finally, the model's been used by all distribution companies in Britain, so the level of buy-in is phenomenal. You know, it's approved by Ofgem. It's been called the most advanced distribution investment planning model ever developed by the Energy Networks Association in Great Britain. So the level of buy-in we have is phenomenal, and it keeps getting better because all the outputs and learning we get from the kind of projects that Dave referenced in the low-carbon arena are all being fed directly into this to improve it. Thank you very much for your attention.
Thank you very much, Mr. Sprawson. So, if you have any question, please keep them in mind, because we have to continue directly with our next presentation, dealing with the topic 6MW fully automated storage at Leighton Buzzard in the United Kingdom. And it will be held by Mr. Björn Lang from Younicos. Thank you for being here.
Okay, the microphone working? Good. Well, good morning, everybody, and thanks to UKTI Invest for inviting me and giving me the possibility to give a short presentation on what Younicos is doing in the UK at the moment, working on the up-to-date largest storage project, energy storage project in Europe. I want to start off to tell you a little bit about where we come from and what the motivation is for Younicos, and it's very much aligned with what you have seen in the presentations before, so I don't need to go too much in detail there. Basically what we see, just to put in a little different way than the other presentation, is a change from a centralized energy system, what we called good old days for the utilities, to a decentralized renewable energy based system in the future, where you do have a lot of challenges to overcome, enable new business, and this is basically what Younicos has gone out to achieve and to support, to make this kind of change possible. Younicos is a Berlin-based company, exists since 2008, and we are currently around 80 people. What we are doing mainly is provision of software, battery management, energy management systems, which you need for the integration of renewables and the integration of energy storage, providing all the communication from the battery to the grid, from the renewables to the grid, amongst each other in a smart mean. If you have looked at the presentation that you've just seen before, we are basically in the part of the enablers for this kind of system change. To give you the short commercial part, there's basically two big advantages of which Younicos can bring into any project, which is on the one side the experience which we have. We have been testing different storage technologies and different manufacturers since 2008. We have an extensive know-how in this regards. We have been working on 3 large projects in the major markets in Europe, in Italy, UK and Germany, where we have multi-megawatt systems. We have a technology center in Berlin where we can show how the integration of the renewable energies can work. On the technology side, we basically work on a system which can integrate different kinds of different kinds of battery storage systems, can allow hybrid systems to find your optimal battery system for each application. And this is basically also what we have done for the project in the UK, where we want to really allow this kind of roadmap, which we see as an integration roadmap for energy storage. So if you look at the integration of renewables, and you see there the renewable energy share on this graph, you have different stages for the integration. The first one is, of course, obviously just connect renewable energies to the grid until you reach a certain level, which will bring problems for the grid stability. This is limited at a certain point due to the must-run capacity of the conventional generators. So the conventional systems will have the problem that they cannot be reduced at times of high penetration of renewable energies any further, but they need to stay on the grid because they deliver really important energy services to the system. So as long as you rely on the conventional generation for the provision of this kind of services, such as frequency control, voltage control, you will not be able to go higher than a certain share of renewables. And this 20% is an average value which we see in larger grids. In the UK it's most likely going to be even a lower value because you don't have the same possibilities as in continental European countries to trade energy with your neighboring countries, and you don't have as much geographically diverse spread of the renewable energy systems. So what you need now is grid stabilizing batteries. We're talking about batteries with minutes to hours of storage capacity, which allow you to provide these kind of services and allow to reduce the conventional generation. It's really just a very short version. If anybody has questions about this, I'm happy to go in more detail afterwards. One project where we're doing this currently, which is a very interesting project, the Leighton Buzzard project in the UK, where we are installing together with different partners. I just draw a short overview here. A 10 megawatt hours, 6 megawatt battery system, which has the purpose of providing frequency control in the grid, but also supporting the grid in providing peak shaving to defer needed investments in the grid infrastructure. You can see that Younicos is providing basically the control software. We're taking care of some engineering part of the design of the system, but mainly the control software and the communication, both internally between the different parts of the battery system, but also all the interfaces to the operator of the battery system and the control platforms. This project is quite interesting because it combines different applications for the battery system, which is the way to go forward with the battery, because it doesn't make sense to use a battery system just for one service, because they can provide different services also parallelly or at different times. In this case, the two services, frequency control and peak shaving. The whole system is quite interesting, as it is part of the Smarter Network Storage program, where we see that the UK has a very good and very straightforward approach to understanding what storage can do and what is possible in the next years and what is needed still, what kind of changes both on the technical side but also on the regulatory framework will need to be done. And it's very extensively supported with different reports that you can download online and give you a good background. One of the major problems, which was already mentioned earlier, is basically the unbundling of the unbundling requirements from the European Union, where it's not possible to use a storage system both on the production side as well as on the grid side, which is basically what we're doing with this project, which is only possible because it's a research project. So these kind of questions are really covered in depth in this research project in the UK, and we think that the market there is very open, has a very good approach to working with these kind of problems and finding solutions. So that's why we are quite interested in going forward working in the UK. We think it's going to be an interesting market for these kind of systems. If you have any further questions to this, apparently it's a very short presentation, but I'm happy to provide more information by email or just come to me, talk to me if you have any questions. So with our company slogan claim, let the fossils rest in peace, I want to thank you for your attention.